Can you hear me?
Hey yo, comms check. This is Roche Orbital. We have been loitering around the Jovian system for a few weeks now. Our solar system has quite the variety of planets for us to explore. But Jupiter has always captivated me the most. Space and the stellar bodies that inhabit it grabbed my attention at an early age. I remember going to a planetarium on a field trip and learning about all the planets we share the solar system with. The instructor started with Mercury, Venus, Earth, Mars, then Jupiter. Seeing this giant for the first time just left me speechless. Growing up in the Pacific Northwest, I was able to experience the beauty of all the forests, mountains, and the ocean. But Jupiter was different for me. Why is this massive amalgamation of gas so beautiful? Earth is a paradise for life and is a work of art on its own. But Jupiter is lifeless. Yet its upper atmosphere is an astonishing mosaic of gas that is under a constant flux, changing every moment from high winds and lightning storms. NASA is also captivated by Jupiter's beauty and launched the Juno mission to explore the entire system. Juno is still active to this day, and our station matched its orbit shortly after we got here. I'd like to talk about Juno today and share its discoveries with you guys. The Juno mission launched on August 5th, 2011 from Cape Canaveral in Florida. Juno traveled 1.7 billion miles at a speed of 150,000 miles per hour to reach Jupiter. After a 5-year-long trip, Juno arrived at the Jovian system on July 6, 2016, and began its research. Juno was equipped with 9 measuring devices to plunge into the depths of Jupiter to record its magnetosphere, atmospheric contents, its auroras, and internal structure. The overall hope was to understand these topics better, so we can glimpse Jupiter's origins. Understanding how this gas giant formed can help us understand the formation of our own solar system, and in turn, use this data to better understand the evolution of other solar systems all throughout the cosmos. Every stellar body in the system plays a part, and gas giants have a large role with their massive gravitational pull. Gas giants often miss the mark for becoming a star ever so slightly, as the leftover gas from a newborn star develops into a gas giant. Gas giants are composed of the same elements that stars are, consisting mainly of hydrogen and helium, but they didn't develop enough mass while forming. The gravity isn't strong enough to trigger nuclear fusion in the core, so they cannot produce their own light like a star can. Let's begin with the heart of this giant, the core. Previous theories of Jupiter's core hovered around the idea of a small, densely packed mass of heavy elements such as iron and nickel. These elements would date back to the beginning of our solar system, and as this heavy debris coalesced into a body, it began to attract more matter around it with gravity. This small version of Jupiter began to suck up all the gas around it, until it eventually became the planet we know today. As a kid, I always pondered the idea of humans flying through the brown and orange clouds of Jupiter's upper atmosphere, eventually landing on an Earth-sized hard-surfaced core. But thanks to Juno's data, we know more about the center of this beast. There is no feasible way to directly see Jupiter's core. The atmosphere is too thick, and the pressures inside the planet are just insane. Sending Juno in for a closer look would unfortunately be a one-way trip. But there are alternative ways of finding clues. While Juno was in orbit, it began measuring the giant's gravitational and magnetic fields. Jupiter rotates on its axis very quickly relative to Earth, with a full rotation taking only 9.9 hours. This fast spin causes the planet to be wider at the equator. This gave Juno changes in speed as it revolved around Jupiter. These subtle speed boosts gave the team back on Earth insights on Jupiter's core, even though it was hidden beneath the clouds. Jupiter's core appears much larger than first thought, filling a large area inside the planet. And instead of a tightly packed core, scientists think the center is more akin to a heavy element soup. Wait, soup, you're saying to yourself? I'm kind of hungry. I could go for some soup right now. Why is this dude talking about soup? No. Stay with me, lad. I got you. Encompassing Jupiter's core is a massive metallic ocean, thousands of feet deep, and full of lightning. Well, maybe not lightning, but this is quite a cool thought. The pressure at these depths is so intense, hydrogen gas turns into a liquid, creating tidal waves of hydrogen. Electrons are ripped off of hydrogen atoms, resulting in a metallic hydrogen fluid, which is very conductive. The core's perimeter is hard to identify apart from this hydrogen ocean, so scientists are calling it fuzzy. Knowledge of the core has improved, but only from clues. So many details still sit in the realm of hypothesis for now. It is thought that this massive hydrogen ocean plays a large role in Jupiter's magnetosphere, which was a big point of research for Juno. As Juno began to research Jupiter's magnetic field, it found some unexpected anomalies. The magnetic poles are asymmetric, which means they are not aligned in the north and south. And on top of this, Juno also discovered some other magnetic sources. These other sources of magnetism may be leading to the asymmetric picture of Jupiter's entire magnetic field. This third source of magnetism has been named the Great Blue Spot, and it exists around Jupiter's equator. This anomaly was unexpected by the Juno team, and very exciting at the same time. The Juno team made the blue spot a new mission objective and set out to uncover the mysteries hidden inside. This magnetic anomaly is not actually blue in color, so don't go looking for pictures of it on Google. It is colored blue on the magnetic map of Jupiter, which is called JRM09 if you're curious. A large dark blue spot would go great with Jupiter's great red spot, but unfortunately, we aren't that lucky. Juno spent 4 years flying by the blue spot in order to record any changes in its properties. With 42 flybys logged, Juno uncovered a few clues. The Juno team confirmed that Jupiter experiences secular variation, which means its poles shift and flux at varying speeds over time. This was confirmed with an amalgamation of Juno's data and Pioneer 10's data from 40 years prior. The Juno team also stated that the secular variation of Jupiter's poles is mainly caused by the blue spot anomaly. It slowly travels eastward, and its rate of movement isn't consistent. And the blue spot's movement is caused by intense winds mixed with charged liquid hydrogen. The crust of a solid planet can interfere while mapping magnetic field lines. But Jupiter doesn't have a thick crust, so Juno has drawn a well-defined picture of Jupiter's magnetosphere for us to appreciate. Now, onto water. Is there water on Jupiter? Well, one of Juno's primary missions was to uncover the answer of this question. Not only if there is water, but how much. When I say water, I don't mean liquid water like we have here on Earth, but the water molecule, hydrogen, and oxygen. It is an important question because Jupiter is the second oldest stellar body in our solar system, just behind Sol in terms of age. After Sol formed, the leftover dust and gas formed a solar nebula around it. The dust began to collide and clump up into larger objects. The leftover gas did the same as it revolved around our baby sun. Since Jupiter was the first planet to form, it's safe to assume its internal contents would be the fingerprints of this solar nebula. Discovering water molecules and their abundance within our local giant could reveal to us the ingredients of our solar system. The Voyager 1 spacecraft approached Jupiter on March 5th of 1979 and as it was flying by, it detected signs of lightning amidst the clouds. Lightning happens when moisture is present. This was our first clue. The Galileo spacecraft launched an atmospheric probe into Jupiter in 1995. The probe didn't last long, but before it burnt up, it beamed back its early readings of Jupiter's upper atmosphere. Its initial data on water content was much lower than scientists estimated, but this number increased as it traveled even deeper. The general thought was that the water content on Jupiter would be evenly spread and measurable. After this brief glimpse, scientists knew there were water molecules on Jupiter, but the volume and the locations were still unknown. So, Jupiter has water. Okay, what's next? The Juno team wanted to know how much and where it lies in the mixture of gases that is Jupiter. Well, Juno has new tech that Galileo didn't. Instead of full sending it into Jupiter's atmosphere like Galileo's probe, Juno can record data from a safe distance using a microwave radiometer. This device looks for certain wavelengths of microwave radiation that is absorbed by water and ammonia. Juno looked deep into Jupiter's clouds near the equatorial belt and found a much larger amount of water than Galileo did. So the upper atmosphere of Jupiter appears to be a blender of elements in a constant state of change like a river. Since Juno is still active, the team is now slowly recording northern regions of the giant to look for more signs of water. But moving back to where we started, yes, Jupiter has water. At the equator, about 0.25% of the molecules appear to be water. Now at this point, I'm sure you're wondering, what about the Great Red Spot? Did Juno look into it? Why is it there, and what's causing it? Well, I have some answers for y'all. Juno passed over the Great Red Spot on its journey and peered through the clouds. The storm is larger than the Earth and has a large amount of mass. This large amount of mass and fast wind speeds have kept it going for hundreds of years, with possible sightings dating back to the 1600s through the first telescopes. Juno recorded a large heat difference in the Great Red Spot compared to other areas of Jupiter, leading to the conclusion that this is an area where large amounts of heat rise from lower regions. This rising heat fuels the storm greatly. Juno also noticed the storm extends much deeper into the planet than previously estimated. Even more exciting to me were the cyclones around the north and south poles of Jupiter. Juno photographed large hurricane-like storms in the polar areas of Jupiter. These storms were surrounded by smaller cyclones, all rotating in an amazing spectacle. These cyclones remained somewhat in formation while Juno observed them over several years. The North Pole storms remind me of the Fell God's Eye from Elden Ring, and the South Pole storms remind me of the Rinnegan from Naruto. I find them both to be beautiful, but at the same time a little unsettling. Juno also took time to explore some of Jupiter's largest moons and uncovered many hidden secrets on them, but we will touch on this in another broadcast. For now, I'd like to thank you guys for tuning in to Roche Orbital today. I hope you learned something new. I feel blessed to be alive in a time where humans are exploring into the stars, even if it's just in our solar backyard for now. I hope we never stop exploring, and maybe one day we can learn to talk through our differences and progress together towards an exciting future. I'm gonna stop yapping and leave you guys with some vibey music and Juno's pictures of our local gas giant, Jupiter. Y'all be easy.